Thank you. My name's Elisha, Chief Technologist here at Amazon Web Services in Australia and New Zealand for the public sector. And today I wanted to spend some time talking about some of the key scientific and social challenges that we see that artificial intelligence can help with. And we often talk about the fact that innovation can transform industries. And it's interesting how much focus there is on this particular technology. I've seen many technologies in my time. And the reason why this one is particularly interesting is because the way that change happens. Now, there's a concept in economics and in ecology called punctuated equilibrium, and it really challenges our self perceived view of how change happens. We as human beings tend to think that gradualism is how things happen, gradually changes, and we'll sort of get used to it as it goes. The world doesn't actually work that way. It goes through periods of long stasis and then massive revolution, huge change, and then it becomes a new normal. And we're experiencing that now with this technology, which I think is quite interesting. Now, I love a good quote, and so I thought I'd create my own quote. And my particular perspective on this, and I'm a technology skeptic in most cases, I like to test things very deeply, been doing this for a long time, is that Gen AI is a feature, not a standalone product. And it's going to be integrated into and significantly impact every knowledge work value chain. If it involves data, if it involves information, if it involves knowledge, it's going to be disrupted. All we're discussing is the time frame and the degree. Now, I want to share some examples with you as we go through today, as well as talk about the technology. And Accenture is a really interesting example here. This is a chemicals company that is using exactly this technology to reduce their development time by 70% and to cut their cost by 80%. They're basically developing drugs in silico rather than in vitro. And essentially, they're going through a much faster cycle of design, manufacture, test, learn, so that they can actually get success quickly. Because the failure rate is typically 90 to 96%. So you can imagine if you can compress that cycle time effectively, you get a far better outcome. Now, what's happened here in this technology is the size of the models and the sophistication of the models has changed dramatically. And you can see just by the parameter numbers over time, that increase has made them exceptionally functional. Now, what's taken place here is not that we have to keep going up that scale to get value. In fact, I expect that to sort of maybe tail off over time in the fullness of time, but we've hit the sweet spot where we can get real value from these models without any training. And so, what does this technology exceed at? Well, it very, very effective at obviously generating content and question answering, so understanding and responding. It's outstanding at summarization, translation, and classification. In fact, it challenges our own, again, perceptions of what human being skills need to be, which is that it typically does a better job of summarization than we do. And so it's changing the work that we do for not a mechanical summarization process, but far more of a problem solving, insight seeking perspective. The summarization is done by the machines. And the shift that we're also seeing there is a real move into the world of unstructured data, images, and video. So multimodal data. The low hanging fruit, if you like, was code because you have a known input and desired outputs. Text was also quite straightforward because it was a case of just converting something from one source to another. But images and audio and video, I think, are really, really interesting spaces that we're seeing dramatic growth in. Pfizer is another example of an organization that's taken advantage of this. And in fact, they've also applied this type of focus to save themselves up to $1 billion annually. And what they're doing is, again, to accelerate the pace of production in the medical sense that development time is not just hugely expensive from a corporate perspective, but significantly impactful from a patient perspective. How fast can we get a new effective medication into the hands of patients is the question. And what was interesting from a Pfizer standpoint is they were able to move into action in just a matter of weeks. It wasn't a case of long drawn out projects. The technology is such that they could move very, very quickly. So how does this get used? How do we apply this? You've even heard in the previous talk about the use of AWS for this technology. Well, what we recognize is that customers need three key ways of interacting with this technology. They need a fully managed machine learning infrastructure for training. So the persona there is around machine learning engineers and data scientists. Then there are application developers, as I mentioned, for whom this is a feature that they want to bake into their particular application. And then there are business users who just want the magic. They just want to use a chatbot, etc., and get access to information. So let's walk through those quickly. So if we start at the base of the stack there, really we're talking about the ability to process huge amounts of information efficiently. And Jeff Bezos was talking about this topic recently on a podcast. I think it's really interesting, is that he reflected on the fact that what our human brain does happens at far lower power consumption than artificial intelligence does. And so at that base layer, we're really focused on innovation at the silicon level through our chips called Trainium, which of course are used to train the models, and Inferentia, which are used to run inference on an ongoing basis. And both of those chips are designed to do this far more efficiently than ever before. And in fact, our recently released Trainium 2 chips have 4 times higher throughput than anything out there. And so what it allows us to do is to process more information and train models far more quickly and consume less power. And this has been used by AI Singapore, who have created models to be able to handle Southeast Asian languages and cultures. Again, the type of data that you're training the model affects the way the model works. And so just because there are these sort of frontier models that everyone knows about, the names are familiar, doesn't mean it works in all regions and all cultures. And in fact, there is a huge space for people to create their own models specific to their locale. In the middle, then we have the app developer who wants to integrate this brand new technology into work they're already doing or new applications. And this sparks a lot of questions. Which models should I use? There are so many. There's a Cambrian explosion of models out there. How can I move quickly? So I need to keep up with what's going on. I want to evolve very fast, but how can I keep my data secure and private? So these are often in tension with one another. So with Amazon Bedrock, what we do is provide you choice. You can choose from any number of different models that exist and bring your own model as well. But the interface, the API is always the same. So you've got that efficiency of software development. You can customize and fine tune your models, and you can apply security and governance with very strict guardrails around that so that the behavior of the models is appropriate to the use case you're applying it to. And as I mentioned, you can fine tune and you can fine tune in a repeated way, and you can even distill models down. So obviously the size of a model affects how fast it operates and how much power it consumes. You can now distill models so you can pull out information that it doesn't need to just focus on your particular use case, which can also make them more efficient. Now, privacy is fundamental here. Again, what we're talking about here is the ability to run your models and third-party models in your own account, in your AWS account, on AWS infrastructure, where you are always in control of your data. The models are not trained on your data. Your data is never accessed or used for anything. It is completely under your control. Now, why is this important? Why is this concept of choice important? And the reason is quite simply that things change over time. If we compare models across different criteria, be it cost effectiveness, hallucinations, latency, etc., we can see that they'll be at different levels at different times. And it seems like we wake up every morning and there's a new model out there, etc. And depending on our use case, we want to optimize for something. May want something that's more cost effective, or we may want something that's faster or presides more conciseness. And so we can do these comparisons and understand where they balance and make a choice. But then we can then introduce a new model, a third model, and see where that fits as well and how that equation changes over time. And we can factor that in. Now, what that doesn't mean using Bedrock is we have to completely re-engineer, rebuild, retool. We simply change one parameter, the model name, and we can get access to the new capability. Another pharmaceutical organization called Al-Nalam, sorry for saying that wrong, has been using this very, very effectively in terms of purely handling triaging product complaints. They created an internal digital assistant to help their employees. And you can imagine with this type of data, you're talking very strict medical and good practice type life science requirements. And they were able to use this technology because of those controls that were in place. And they cut down their reporting and initial evaluation and response time to 3 to 4 days to just hours. And they could provide an answer in 30 seconds instead of 15 minutes. So you can understand the productivity impact of applying this technology wisely. And then finally, there's the people who just want to access data quickly and just use it. And that's where our tool called Amazon Q comes into place. And Amazon Q allows you to access your information in your corporate environment through an intelligent chatbot that looks and feels like your systems. And Bayer applied this because they recognized that just onboarding their staff was taking too long. And so they're able to cut that onboarding time by 70% because they just made it easier for people to find information that they needed. Then they applied this same technology to the developer community, and their productivity went up by over 30%. So they could develop more quickly because they had tools helping them develop their code and understand their code and document their code. Education is another area where this is dramatically changing the space. In fact, it's interesting at the moment to share a quick personal anecdote. My eldest child just finished the last year of high school here in Australia, and he was told very specifically by his teachers, you cannot use any of this type of technology in any of your work. It's grounds for expulsion. Don't do it. My daughter, who is 3 years younger, so she's 15, entering, I guess, what you call middle or senior high, she was told by her teachers to make as much use of this technology as you like, because that's what you'll be using when you enter the workforce. So the shift is already taking place, which is interesting. But it can also help us in education. It can become an intelligent virtual tutor that can adjust its answers appropriately to the person it's working with on the fly. You don't have to have an expert tutor, a median tutor, and a layperson tutor. Obviously, summarizing content, it is amazing. So generating flashcards and testing information is really effective. It can also augment additional courses and make them better and help you create new experiences as to how students are going to learn. But purely from an educator standpoint, it can do things like this. It can take a particular set of information and generate questions and answers based upon different criteria. So in this case, we're saying, I want you to generate me 4 easy and 2 difficult questions for a quiz about the concept of history. And you can see it will come up very quickly with that correct level of expertise and understanding, which means we can meet students where they are, and you can understand from an educator standpoint, this takes away all that time that it takes to write good questions. They review the questions, they inspect the questions, but they don't have to write the questions. Now, of course, this has to be done securely. So there's a huge amount of focus on having governance and compliance, the ability to guide how this technology is used. What is a mistake is to ban the technology, so you cannot use it, because people will use it anyway, and then you're getting a bad outcome because they're probably using third-party tooling. You want to make sure that the things that are being used are the right things. Of course, there's a requirement to maintain control over data, encrypt data, and support regulatory standards. So understanding where the data is, where those models run, becomes fundamental. Controlling how decisions are made and how systems are used is really important. That's why human in the loop technology is vital, as well as threat modeling and risk management. And then once these tools are used, they need to be available, much like the internet needs to be available, because they get brought into every single use case. Another interesting element of generative AI is that about responsible use. And this is where customers are talking a lot about, well, how do I demonstrate that there is fairness, that there's transparency? How do I explain the decisions that were made by the model? And so the technology has evolved substantially since launch, where now we can explain why a model made a certain decision and what its reasoning was. And this is allowing us to have greater insight into the decision making and the operations of those models. Now, I wanted a quick demonstration. It has sound. I don't think the sound's going to work, but it's okay because it also works with some overlaid text as well. But basically, this is a tool that uses generative AI to analyze medical data. I think it's fascinating because it's an AI assistant, and it can look at this particular X-ray study. And in this case, I've said, "Hey, what does this image show me?" And it will give a very complicated.
The current chest radiograph demonstrates the presence of a left approach pigtail catheter. The previously noted moderate left pleural effusion has decreased in size, now characterized as a small effusion with adjacent streaky densities that may be related to scarring or atelectasis. There is persistence of blunting at the left costophrenic angle. Cardiomediastinal contours appear normal, and there is no evidence of bony abnormalities. The interval placement of the pigtail catheter since the last examination suggests an intervention, likely for the management of the pleural effusion.
Now that sounded right, but I'm no doctor. So I'm going to ask it, what does that actually mean from a layperson's perspective? And what's magical here is what it does in real time.
The latest chest x ray shows a tube in the left side of the chest to help drain fluid. The amount of fluid around the lung has reduced compared to the last x ray. There are some irregular lung markings near the fluid, possibly due to healing or partial lung collapse. The heart and the middle part of the chest look normal, and the bones of the chest wall are normal as well.
So you can imagine how useful that would be for a patient. But I know my audience, and although I'm not over there, I understand where you are. So I wanted to also demonstrate the multilingual capability, which I find fascinating here. So I'm going to ask a very similar question, but tell it to answer in Korean. So you can judge how good or bad a job it does.
환자는 좌측 4, 5, 6번 늑골에 골절이 있으며 특히 5번 늑골은 변이골절로 보입니다. 중등도의 좌측 흉막 삼출 및 좌측 폐에 기저부 침윤이 있는데 이는 폐쇄성 폐렴으로 여겨집니다. 우측 폐는 깨끗하고 심장 비대나 우측 횡격막 이상은 없습니다. 그리고 경도의 흉추 후만증이 관찰됩니다. 종격동은 정상 범위입니다. 좌측 늑골 다발성 골절이 확인되고 이와 관련한 흉막 삼출과 좌측 하부 폐엽에 침윤이 있는 것으로 평가되며 폐기종은 관찰되지 않습니다. CT를 통한 추가 평가가 권장되며 다른 늑골 골절도 존재할 수 있습니다. 흉막 삼출이 혈흉으로 이어질 수 있는지 그리고 흉막 질환의 조직화나 섬유화 흉강의 가능성도 고려해야 합니다.
Now, I'm guessing that was pretty complicated. So I'm going to ask it the same question, give it to me in layperson's terms as well. And again, you can assess whether it's a good layperson answer.
환자분은 왼쪽 가슴뼈 여러 개가 부러졌고 그중 하나는 제자리에서 움직여버린 상태입니다. 또한 왼쪽 가슴 안에 액체가 조금 차 있고 폐의 일부가 제대로 펴지지 않아 그 부분이 살짝 어둡게 보입니다. 그런데 오른쪽 폐는 깨끗하고 심장 크기도 정상입니다. 목이나 등이 조금 굽은 것 외에 다른 이상은 발견되지 않았습니다. 추가적인 정밀 검사를 통해 정확한 상태를 확인할 필요가 있습니다.
So I think that made more sense. Certainly when I did the English to the Korean to English translation, it seemed to be. But it's just interesting to see what this technology can do. As I say, this is a feature that is unbelievably useful. So the question, just skip forward there. So one of the challenges we face, of course, is skills. And we know that a lot of people are trying to access this information and this capability very, very actively. And so we're providing online digital courses that allow people to get up and running, including a lot of free courses on this technology, because we generally believe that the change is happening and people need the skills to make the most of this new technology. But what about a strategic viewpoint? So 2023 was really the year of proof of concepts. You know, what is generative AI? How do I get started? What do these words mean? What should we try? Let's poke a little bit about it. 2024 has really been the year of production for some people. As you can see, lots of customer stories, lots of case studies. And people are starting to ask questions about, how do I prioritize? What customization should I do? How do I scale? What's the right model? How's my risk management going to look? How do I lower my costs if I'm using this technology? And so, really, there are three key steps in getting moving here. The first is to select the right use case. And to do that, it's really about assessing fit against a raft of criteria, including things like your team structure, timelines, risk, budget, and feasibility. And then you plot all these different options across a graph. On the left, we have the value axis, and on the Y, we have the on the bottom, we should say the X, we have the feasibility axis. Now, in typical terms, you'd look for the thing that has the most value, wouldn't you? Not in this case. You should actually be looking for the things that have the highest feasibility, because this is a new technology and we want to get familiar with the technology before we try the harder things. Then, once we've identified we want to do some things, we need to empower our teams. We need to train them and give them the understanding so that they can move forward with what they're doing. That could be classroom training, that could be online training, that could be full credentialing. But skills are vital to make the most of this technology. And finally, it's about getting moving. Now, the good thing is you don't have to build from scratch. There are hundreds of use cases that are already out there. There are things in the marketplace that already exist that you can simply get off the shelf and integrate. And of course, partners that have these capabilities too. Everyone's asking about this. Everyone's interested in using it. Partnering with an organization that can help you move quickly can accelerate your own journey. So, to summarize from a strategic perspective, you need to go in with this eyes wide open. This is a world of continuous experimentation. Things are changing very, very rapidly. So, picking horses and taking dependencies early on is not the right thing to do. It's not a one size fits all. As I mentioned, it's an enhancement, not a replacement. And it differs depending on the space, the industry, and the skill set that you're dealing with. It's important to be very, very flexible. So the ability to change and evolve as the technology changes and evolves is vital. And fundamentally at AWS, we always say work backwards from your customers. You want to understand from your domain experts how to use this in the right possible way, not assume that they may want to use it or how they may want to use it. So with that, I'd like to open the floor to any questions that people might have.
Thank you. Yeah, thank you, Simon. So, anyone have a question for this presentation? No. Okay.
Was the
Simon.
Korean okay? You tell me. Was the Korean okay? I have my question for you.
I think it's no question. I have a question for you. Okay. So actually, you introduced a couple of real world application. To explain the generative AI. So, one of that you introduced generative AI for the education, right? Yeah. So
Yes.
what is the what's your future next AI for generative AI for the education? Yeah.
I think the next thing we'll be seeing. So at the moment, we're seeing, as I mentioned, that course creation, individualization of exams, etc. I think really where the next step is what the learning experience looks like. So the ability for the AI to understand where the student is at with their knowledge and how they like to best learn, and then dynamically tailoring the course content for the student. That's going to be really, really interesting, particularly as we see some of these audio visual capabilities coming in. You can imagine a student who learns better through visual cues versus maybe written material may benefit from having that information provided to them proactively versus being forced to sit and read a book like everyone else does. So I think the methods, the pedagogical methods of teaching are going to change a lot with this technology.
Yeah. Great. Yeah. Maybe no question. Yeah, Simon. Yeah, thanks for great answer. Also, and then
Thanks.
great talk
Thank you very
again.
much.
Yeah.
Thank you
So
so much.
thanks for attending for Korea AI Summit 2024. We hope for the meet 2025 also. Okay. Yeah, thank you.
Thank you very much.
Yeah,